Hello everyone. So today I'm going to talk about browser fingerprinting and in particular about an experiment that we did at EFF to measure how fingerprintable web browsers were called Panopticlick. So let's start before we get to browsers, let's talk about identifying information. Now when we ask, well, what kind of information identifies a person? We have some standard sorts of answers, like, oh, if I know their name and address, I probably know who they are. But there are some more surprising examples of identifying information. There's a paper by LaTanya Sweeney from the 90s that shows you know someone's zip code and their date of birth and their gender, then you have about an 80% probability of being able to identify them uniquely. Now that's a bit surprising and counterintuitive, so let's see how it happens. If you start with 7 billion people on the face of the planet Earth, you rapidly narrow yourself down, if you know a zip code, to a group of about 20,000 or maybe 50,000 people, maybe in some cases 100,000, but not very many. And then you can divide that number by 365 because you know their birth date. You can divide by a more complicated number that's about 70 because you now know how old a person is. And then you can divide in half again because you know whether they're male or female. And it turns out that if the zip code you started with had fewer than about 50,000 people in it, you now probably have a unique person at the end of this process. So there's a mathematical measure you can use to say how identifying a set of facts about a person is. Or how much information is required to identify someone. And if you need more bits to identify them, then each bit doubles the number of possibilities. And if you're learning more facts about them, then each bit you learn halves the number of possibilities. So you can think of these as trading off against one another. So for instance, on the face of the planet Earth, with 7 billion of us people, you need about 33 bits to learn the identity of one of us. And if you learn someone's birth date, what day of the year they were born on, you learn about 8.51 bits. So if we talk about a random variable you might measure, like someone's birth date, you can talk about the amount of information you learn when you learn a particular value of that random variable. So if we're talking about birth date, and you learn that my birth date is the 1st of March, then you've learned 8.51 bits about my identity. If, however, you learn that my birth date is the 29th of February on a leap year, then you get a bit more information because the likelihood of that being true is only a quarter of what it would be for any other birthday, so you get more information, 10.51 bits, typically. So we call that first measurement the surprisal or self-information of a fact you've learned. So surprisal that I was born on the 29th of February, 10.51 bits. And then we can talk about the entropy of this type of measurement, which is the expectation value of the surprisal. So if you have a probability distribution, you measure the expectation across all of that. There's some formulas you can use to look at this. We have a paper on our website that has all the mathematics in a bit more detail if you're interested in it. A point to note is that you can't add surprisals together. If you learn someone's birth date and then you learn what city they were born in, those two things are probably independent variables. Not entirely, but close to. So you could add the number of bits together. But if you already know someone's birth date and then someone tells you their star sign, you're actually not going to learn any more information. So if you want to know how two of these measurements add together, you need to do some fancy stuff with conditional probabilities. So what use is all of this theory? Well, we can apply it to tracking web browsers. Now what do I mean by tracking web browsers? Two things. One is if you go to a website on day A and then you come back 3 weeks later and you do something else, can the website link those two acts of yours together? And also, if on a given day you go to 2 different websites and you maybe look up one fact on one and then another fact on another, and then the question is, could these 2 sites get together and combine the facts and get a deeper picture about you? Either of those would be tracking. Now, there are at least 3 ways that are widely discussed to track web browsers. You can use cookies, which are these little bits of information your computer will store and send back, and sites can put serial numbers and tracking numbers in them. But of course, we all know about, we're at DEFCON, everyone here knows about cookies. You all have browser settings to delete them or limit them. So well, we can survive cookie tracking. And IP addresses, everyone knows about IP addresses, but IP addresses can be hidden by a proxy server, or you can move from your house to your friend's house to the cafe to work, and each time your IP address changes. Lastly, there are these quite nasty things called super cookies. The most infamous example being flash cookies. They are essentially exactly like cookies, except when you tell your browser not to set cookies, Flash still has some other settings page that you haven't changed somewhere, and so Flash is still storing its own kinds of cookies. And you can think of these things as hoops that you have to jump through in order to get privacy on the web. If you want to not be tracked, you have to avoid tracking by cookies, avoid tracking by IP addresses, avoid tracking by super cookies, and then if you do that, it's time to talk about whether you can be tracked by a fingerprint. So fingerprints are like Latanya Sweeney's example of tracking someone with some inane facts like their zip code and their date of birth. Turns out that the characteristics that web browsers have, like the version of the browser, what operating system it's on, etc., combine together in the same way as those other facts, and perhaps they make your browser unique. Now, there are different degrees of uniqueness that you might get out of the version information on a browser. You might have complete global uniqueness. So you sitting there in the third row, your browser is completely unique in the whole wide world. And we know it. When we see you, we can track your browser. But perhaps that's not true. Even so, browser fingerprints may be a problem because they mean that your IP address combined with your fingerprint is uniquely identifying. So if you guys all have your laptops open and you're surfing during my talk, please don't do that. But if you do, then perhaps there are 2,000 people behind a proxy server here at DEFCON all surfing at once. And so that gives you some degree of anonymity. Except if you all have fingerprints that are not unique in the world, but unique at DEFCON at least, then that would be a tracking mechanism. Another possibility is that fingerprints don't track you all the time, just whenever you go and delete your cookies, your fingerprint is unique enough to link your old cookie to your new one, to give you a new copy of your old cookie back again, a zombie cookie if you like. And the last thing that makes fingerprints really nasty is that unlike cookies, they're automatically the same when different sites collect them. So if a website over here sees your fingerprint and a website over there sees your fingerprint, they see the same thing. If they both tracked you with cookies, they'd get different cookies, and they'd have to have some sneaky process to link them together, whereas fingerprints are automatically the same. So we heard a lot of rumors at EFF about fingerprints. We heard that some web tracking and analytics companies had started using them. We heard rumors that web-based DRM systems were using fingerprints to track people. We'd heard that they were being used as a backup authentication mechanism for financial systems, which is maybe less of a problem than the first two. And we got really curious about how effective this method was. And we were also worried about a more mundane question, which is every single time you go to a website, almost all websites are configured to log your browser's user agent string. And we were wondering how much of a problem that was. So we decided to get some numbers to find out. So we put up this little website, panopticlick.eff.org. And if you went to that website, or if you still go there, you see a page like this that tells you what's going on and then gives you a little button you can click if you want to be part of the experiment. And if you click on that, you get a page that looks like this that says, oh, your browser appears to be unique, at least up to 20 bits, possibly more of identifying information coming from your fingerprint. And then there's this little table here showing what all the component measurements were and how identifying each of those were on their own. So you can see there's a user agent string, there are accept headers, plugin details, etc. Really telling stuff in there, there's fonts. I'll talk about where these came from more in a second. So these are the 8 measurements we had. These top 3 were they're just things that you always send to a web server when you ask for a page. The next 4 come from JavaScript. So there's a little bit of JavaScript that runs in the page, and if your browser supports JavaScript and it doesn't have it disabled, the JavaScript will collect this information and send it back to us with an HTTP post command. And lastly, if you have Flash or Java installed, we'll go into Flash or Java or both and ask those plugins for your list of system fonts. So we have these different measurements. It'll turn out that the two most problematic ones, they're all kind of problematic, the two most problematic ones are these plugins here and these fonts at the bottom. So there are a lot of things we didn't collect, but which you could use to make these fingerprints even nastier. And in fact, it turns out we've since seen that there are companies in the private sector that will sell you a fingerprinting system that doesn't just do the kind of 8 things we did, but actually also does a lot of this other stuff. One particularly nasty thing is you can measure the clock skew of a quartz crystal. That is how much faster or slower than another clock your computer is. And that's very hard to hide, and it's unique to your hardware rather than just your software. You can measure the characteristics of the operating system's TCP/IP implementation. You can measure the order in which the headers show up. There's lots of stuff in the ActiveX, Silverlight, and other Adobe libraries that we didn't have time to dig through and find and use, but you can do that. There are quirks to the way that each browser has implemented JavaScript that could be identified with the right code. There's a really nasty bug that's just recently started being fixed in browsers where you can measure the history of a browser using CSS detection. And some of these things we didn't collect because we just didn't have time to implement them. Some we didn't collect because we didn't know about them. Once we put the site up, we got a lot of emails saying, hey, you could collect this thing as well. And lastly, some things like this CSS history, we weren't sure would be stable enough to include in a fingerprint without some kind of fuzzy matching code that we didn't have. So all of our results, I guess the point here is that all of our results should be taken as a kind of optimistic story about how much privacy you have. With a really good fingerprint, the fingerprint is more powerful and more revealing. So the way we handled the data off our site, we set a 3-month persistent cookie, and we stored an encrypted IP address with a key that we threw away. And we used those primarily to avoid counting you twice. If you came back, we wanted to know if you had, if you were the same person with the same fingerprint or another person with the same fingerprint, because those are two very different things. And we had an exception for that, which is if at a particular IP address we saw cookie A and then cookie B and then cookie A again, we thought that's probably, or at least potentially, evidence that there are more than 2 computers behind that IP address, that perhaps behind a NAT firewall, that have the same fingerprint. And that could be important because it could be a sign that there's a corporate network there and there's some sysadmin who clones all the same code out onto all the machines every day. And so there are genuinely multiple machines with identical fingerprints there. And that gives the people in that office some protection. So we decided not to treat those as repeat visits from the same browser if they were interleaved. One thing to note is a lot of people were confused by the numbers we had on our site. Those use the cookies, but not the other methods of avoiding double counting, because we had to compute that stuff on the fly for millions of visitors. The data set I'm presenting in this talk has more fancy control for that stuff. So we got a pretty big data set. We had 2 million hits, about 1 million distinct browser instances there. The people that we were measuring are not representative of the entire web user base. They're people who read Slashdot or Boing Boing or come to the EFF site. And so they're more of a data set of privacy, people who know about and care about privacy. However, as I said before, you have to jump through 3 hoops to not be trackable already on the web. And so we think this is kind of the relevant data set to ask, do people who block cookies and know about IP addresses and how to hide them and so forth end up being trackable by their fingerprints instead? And another point is that the data in this talk is all based on the first 470,000 odd instances, so the first half of the data set. Turned out people were really unique. 84% of the browsers that came to our test site were unique completely in the data set. If you split the data set up and say, let's just look at the browsers that have either Flash or Java installed, and that's the relevant set if you're talking about desktop browsers, your uniqueness rates go up